Okay, guys, today we're talking about anaerobic fermentation. So anaerobic means no oxygen is present. So if you recall, glucose goes through glycolysis, we make pyruvate. If oxygen is present, then it can enter into the mitochondria, uh, go through the Krebs cycle, go through the electron transport chain, in turn making a ton of ATP. But if oxygen is not present, then we're going to go through fermentation, either ethanol or lactate, depending on what type of organism we are. So um, during anaerobic respiration, cells can utilize glycolysis to make ATP. So remember, glycolysis only nets us 2 ATP compared to 38 if we went through the electron transport chain. So it's only about like 5-6% of the total net ATP if oxygen was present. So remember, cells without mitochondria can only go through fermentation because there's no mitochondria or no oxygen. And glycolysis couples with fermentation to produce ATP, and that's what we're going to talk about. So before we do that, here's just a picture of glycolysis, and this is important. If you remember, NAD gets reduced to NADH. So in the process of glycolysis, we're making a bunch of these NADH molecules. And the whole purpose of these NADH molecules, if oxygen's present, is to bring it over to the electron transport chain to harness the energy in these high electron carriers. But if there's no oxygen there, then what's the point of having these? Well, there is a point. And it's going to help with the process of fermentation. So we got to understand that these NADHs are very important for fermentation. And remember, every living thing goes through glycolysis. It's the most primitive form of respiration. Okay. So lactic acid fermentation is the first one we're going to talk about. So this occurs in humans and mammals. So if we look at the picture here, glucose goes through glycolysis and it produces 2-pyruvate. And it's going to net us 2 ATP in the process. Small amount of ATP, but we'll use it. That pyruvate is then going to get reduced from the NADH that was made in glycolysis. Remember this NADH? So this NADH is going to reduce the pyruvate, and that's going to turn into lactate. As the NADH reduces the pyruvate, it itself gets oxidized and become NAD+. Well, this NAD+ is important because glycolysis is going to use that NAD+ to kind of regenerate this thing and keep it going. So this NAD+ keeps glycolysis going, and then the NADH from glycolysis is going to kind of keep this fermentation process going. So we're going to create lactate. It's a very easy step. NADH reduces pyruvate and we make lactate. Okay. Lactic acid, I'm sure everyone in here has felt lactic acid before. You're working really hard, your muscles start to burn, and you get really fatigued and sore. That's the lactic acid or the lactate building up in your muscles. It can cause rigor mortis in cows. It reminds me of the time where I had a raccoon on my roof for the entire day. The guy didn't come and get it. And I came home after work. It was like 100 degrees that day. It was up on a black roof, and it was up in the air like this, arms and legs, and it had completely gone through rigor mortis. There was hardly any oxygen on that hot roof because it was all rising. It didn't get any water, and it was I remember it was stiff as a board. So lactic acid will build up in the muscles, but it can also be converted back into pyruvate. So once that lactate builds up in the muscles, it'll go into the blood, the circulatory system will carry it into the liver, and that lactate in the liver will in turn get turned back into pyruvate, and then it can get turned back into glucose. And it can store in the liver as glucose. And when those glucose start building up and making polymers, it's gonna turn into glycogen. If you remember, glycogen is that energy storage in the liver that we talked about back in the last unit. Okay? So that's kind of what it looks like. So lactic acid can be converted back to pyruvate, and if you ever see athletes jump in ice baths, that's one of the reasons it actually helps. It helps with inflammation, and it helps so that the muscles really don't feel sore afterwards. LeBron James, he actually built his own like cryogenic freezing machine in his basement, and he used it after every single game, and it just helps with the inflammation and it helps with soreness. So I don't know if you guys have ever, you're probably going to end up playing. Well, let's just pause that. Okay, I just went back to try to edit that, but apparently I got to buy the update to do that. So sorry about that. Okay, moving on. So application of lactic acid fermentation, bacteria uses it. So when you put bacteria in yogurt or milk, it produces lactate. That lactic acid is acidic and it breaks down or denatures the proteins in the milk, and you can make cheese or yogurt by doing that. So you could pause the video for a second if you want here and try to answer these questions. Okay, so why does the body feel fatigue when it's undergoing anaerobic respiration? Simple. Well, one, we're not making a lot of ATP. We're not making a lot of energy, so you're going to feel fatigue. But also, that production of lactic acid burns, and it makes your muscles feel very sore and heavy. And why does rubbing aching muscles often help reduce pain? Well, when you rub your muscles, you're literally pushing that lactic acid into the circulatory system so that your circulatory system can wash it away so that the liver can break it down. All right. Okay. So getting out of lactic acid fermentation, moving into alcohol fermentation. This is one of my favorite ones. So yeast will do this, and it'll take the pyruvate made from glycolysis, and it actually has two steps instead of the one. So pyruvate will turn into acetaldehyde, and then it'll turn into ethanol. And ethanol is what we can drink, and it's the alcohol in booze or wine or beer that get you drunk. So acetaldehyde takes electrons from NADH and regenerates into NAD, same thing as our other fermentation. And it also produces CO2. This is a little bit different. So let's look at it. So glucose makes 2-pyruvate. In turn, we're going to be making 2 ATP. And then that pyruvate is going to get decarboxylated. So our 3-carbon pyruvate is now going to turn into a 2-carbon acetaldehyde. And then that acetaldehyde is going to get reduced to become ethanol. That NADH is going to turn back into NAD, and NAD is going to go and allow glycolysis to regenerate so that this cycle can continue. So very similar to lactic acid fermentation, except we have this decarboxylation step in there. So this is going to produce a little bit of carbon dioxide. So on top of making wine and beer, we also use it in the production of bread. So if you ever see the bubbles in the bread, that's the yeast. That's the CO2 production. The more yeast, the more CO2, the more airiness in your bread. So lactic acid fermentation, for a summary, you got 2-pyruvate, makes 2 lactic acid, NADH turns into NAD. In alcohol fermentation, you get 2-pyruvate turn into acetaldehyde by releasing the carbon dioxide, and you're going to get 2 ethanols. So kind of going back to this, it's pretty easy actually to make wine. When I was in high school, when I was in grade 11, the grade 12s as a project made wine. They actually had a wine and cheese party. They got to drink the wine. They were underage and they got to drink the wine. I don't know how it flew, but they did it for years. And then sure enough, the year that I was in grade 12, they had to stop doing it. But if you take yeast and you put in some wheat and some sugar or some dried fruit or some grapes, that yeast will start breaking down the sugars in there, and it'll start to produce CO2. You don't want the CO2 unless it's like beer where it's carbonated. So you can get rid of that. You can allow it to escape, but you're going to be left with ethanol. And the more and more the ethanol builds up, eventually it's going to kill the yeast, and the yeast will settle down to the bottom, and you distill it, and you're going to be left with wine or beer. So if we look at our molecule count for anaerobic respiration, each one of these go through glycolysis. Glycolysis makes 2 ATP and it makes 2 NADH. Okay. Fermentation, it doesn't make any ATP at all. It actually uses up that NADH to make NAD so that glycolysis continue again. So anaerobic respiration only nets us 2 ATP. It's something, but it's better than nothing. So there's anaerobic respiration. If you guys have any questions, hit up that Google Doc and I'll answer away.